Hello. Hello students and welcome to this video on binomial theorems and multinomial theorems. So this is the last video. In this video we will solve 7 more questions up to 267 and we will finish this chapter. Then we will move on to determinants and matrices. The link to download the PDF will be in description, as well as at the end I will show you how you can download and maintain updated copies of the PDFs. I will also show you my website where you can come and ask questions or give answers to questions. So without further ado, let's get started. Question 261 says that sum the series 1 upon 2 factorial plus 3 upon 4 factorial plus 5 upon 6 factorials and so on up to infinity. So if you look carefully, our series is 2n minus 1 upon 2n factorial. So this is 2n minus 1 numerator and denominator is 2n factorial, which is equal to 1 upon 2n minus 1 factorial minus 1 upon 2n factorial. So t1 becomes 1 upon 1 factorial minus 1 upon 2 factorial, t2 becomes 1 upon 3 factorial minus 1 upon 4 factorial and so on. So essentially our sum is 1 minus e to the power minus 1. Question 262 says that sum the series 1 upon 2 factorial plus 1 plus 2 upon 3 factorial plus 1 plus 2 plus 3 upon 4 factorial and so on up to infinity. So our Tn becomes 1 plus 2 plus up to n upon n plus 1 factorial, which is equal to n upon 2 times n factorial, which is 1 upon 2 times 1 upon n minus 1 factorial, which is nothing but e to the e upon 2. Question 263 says that sum the series 1 cube upon 1 factorial plus 2 cube upon 2 factorial plus 3 cube upon 3 factorial and so on up to infinity. So our nth term becomes n cube upon n factorial, that is n square upon n minus 1 factorial, which we can write as n square minus 1 plus 1 upon n minus 1 factorial, which becomes n plus 1 upon n minus 2 factorial plus 1 upon n minus 1 factorial. Now we solve n plus 1 upon n minus 2 factorial. We can write that as n minus 2 plus 3 upon n minus 2 factorial, which is 1 upon n minus 3 factorial plus 3 upon n minus 2 factorial, and the sum will become 5e. So you need to do a bit of exercise. If you have questions related to this, you can come and ask question on my website. Question 264 says that prove that 1 minus log of 2 is equal to 1 upon 2 into 3, 2 times 3 plus 1 upon 4 times 5 plus 1 upon 6 times 7 and so on up to infinity. So we see that the series is 1 upon 2 minus 1 upon 3 plus 1 upon 4 minus 1 upon 5 plus 1 upon 6 minus 1 upon 7 and so on. Now log of 2 is 1 minus 1 upon 2 plus 1 upon 3 minus 1 upon 4 plus 1 upon 5 minus 1 upon 6 and so on. And thus 1 minus log 2 is equal to 1 upon 2 times 3 plus 1 upon 4 times 5 plus 1 over 6 times 7 and so on. Question 265 says that prove that log of 1 plus x minus log of x minus 1 is equal to 2 times 1 upon x plus 1 upon 3x cubed plus 1 upon 5x to the power 5 and so on up to infinity. Now we can write this as log of 1 plus x minus log of x plus log of x minus log of x minus 1, which is equal to log of 1 plus 1 upon x minus log of 1 minus 1 upon x, which gives us the desired equality or rather expression, that is 2 times 1 upon x plus 1 upon x 3x cubed plus 1 upon 5x to the power 5 and so on. Question 266 says that prove that 2 log x minus log of x plus 1 minus log of x minus 1 is equal to 1 upon x squared plus 1 upon 2x to the power 4 plus 1 upon 3x to the power 5 and so on up to infinity. So we can write this expression as minus of log of 1 plus 1 upon x minus log of 1 minus 1 upon x. So this should be, let me think, this should be plus, I believe. Both are minus. We take minus out. So minus log x and minus log x. This should be plus over here. Okay. And you simplify, you will get the series. Question 267 says that prove that log of 1 plus x to the power 1 plus x times log of 1 minus x to the power 1 minus x is equal to 2 times x square upon 1 dot 2 or 1 times 2 plus x to the power 4 over 3 times 4 plus x to the power 6 over 5 times 6 up to infinity. So it seems the bigger bracket, or rather the square bracket, is at wrong place. Okay, so this we can write as 1 plus x log 1 plus x plus 1 minus x times log 1 minus x. So yeah, definitely square bracket is at wrong place. We don't need a square bracket. These two are different terms. So we write the expansion. It becomes 1 plus x times 1x minus x square by 2 plus x cube by 3 over 3 minus x to the power 4 over 4 and so on, plus 1 minus x times minus x square over 2 minus x cube over 3 minus x to the power 4 over 4 and so on. So we multiply and add, we get minus 2 times x square upon 2 plus x to the power 4 upon 4 and so on, plus 2x times x plus x cube upon 3 plus x to the power 5 upon 5 and so on. So the series becomes x square upon 1 times 2 plus x to the power 4 upon 3 times 4 plus x to the power 4 times 5 times over 5 times 6 and so on. So if you want even more detailed solution, let me know. I think there is dots missing here. So there seems to be certain typing mistakes. I'll fix these. Okay. Now I'll show you my website, astavakra.org. You can download algebra, trigonometry and coordinate from second, third and fourth links. The PDFs are available, as well as you can read the HTML format of coordinate. Note that if you download the PDF, then this is the date on which it is modified, and you should copy and put this date in the PDF you have downloaded. After 15 or 30 days, you should come back and check whether the date has changed, and if the date has changed, then you should download the PDF again and update the date of your downloaded PDF. Now about HTML format, it makes use of Mathml. So the best browser to read this is Mathml. Mathml has Firefox has best support for Mathml. So Google Chrome and Safari and Edge also support Mathml, but it might not be as mature as Firefox. Now one more thing is that I cannot put these dates really in the PDF, because if I put the date in the PDF, then existing links will break because the date will change. So it is not possible for me to put the date in the PDF itself. Also, the question answer application which I was talking about, this is the question and answer application which I have developed. If you have questions, you can come ahead and ask the questions. I have created the tags for you: algebra, calculus, coordinate geometry, probability, trigonometry. And if a tag does not meet these your question, then you use simply the mathematics tag. So let's build a community together and learn from each other. Okay. If you have questions, please feel free to ask. And if you see a question which is unanswered and you know the answer, then please answer those questions and we grow together. So now that we have finished binomial theorems, so we will start with determinants. Compared to other chapters, there are relatively less number of problems in determinants, only 184 problems. So we should be able to finish this between 20-22 days, something like that. So determinants are a relatively simple topic, and matrices are also relatively simpler topic. So I hope that you will be able to master the topics of determinants and matrices like other topics. So I'll take my leave, and I hope that you enjoyed this video and found it useful and learned something from it. So I'll meet you again tomorrow with 10 more with theory of determinants, and till then, you stay curious, keep learning, and most importantly, enjoy.